Hello, this is Ron. I have a quickie, mainly for notes for myself. First I want to show you my battery pack. It's coming in at 9.76 right now. That's the AA battery pack you're looking at right there. Okay, here's the overall scene of carnage. There's stuff everywhere. And let's go right to it. What you got there is a 6-watt bulb being driven by a battery pack that is 9.76 volts through a bunch of stuff. We'll get to that in a minute. And if I can make my tripod stand still. So the battery pack is 9.76. I am drawing 30 milliamps. And I am driving a light bulb very brightly that requires 120 volts at 54 milliamps. Now this light bulb is very bright. Camera compensates. All the light goes forward at 180 degrees. So you'll have to trust me that it's very bright. Probably didn't show up that well on camera. And let me back up now and tell you all about this. Okay, this is my little schematic for EMF power production. I created a 555 timer with variable frequency and duty cycle to figure out how to make EMF shoot out of coils most effectively. So you can see the 555 timer, and its square wave output is driving a transistor, and the transistor is turning a battery on and off, causing this coil, whatever the coil is, to energize and then sharply cut off and then wait, and the coil produces EMF, electromagnetic flyback. So let's take a look at the table again. So in overview from the last video, this is another shorty. That's a 555 timer surrounded by buffering so I don't burn the chip out. Those little blue things are trimmer pots, 1K. I can't be very precise with them, but precise enough to get the idea. I have more potentiometers coming to replace those, so I can be more specific, more detailed later on. But basically the timer is driving that transistor. Transistor is turning the battery pack on and off. Battery pack is charging a automotive relay coil. Coil is discharging into a full wave rectifier, just 4 diodes, and I have that now going into a transformer. This transformer is an unknown. I think it's either a 2-to-1 or 3-to-1, and I'm using it to ramp the voltage up. And all that comes over to a 6-watt light bulb. It's an LED. The requirements on it say it needs 120 volts at 54 milliamps to light fully. So I'm giving it very close to what it needs. And let me turn this circuit on again. I am pulling ridiculous low amperage. Excuse me, this tripod's not the best. I'll just plug this in again. I am using ridiculously little amperage to drive this. If I can get that accurately here. It is on 30 milliamps right now. That's incredible with a 9.76 battery pack. So let me tell you what I've learned so far. So for good EMF power generation from a coil, size of the coil isn't very important. What is important is the duty cycle. Duty cycle of 85% is best. I found that if you go over, that is, I should specify it in case you don't know what duty cycle is. that means the battery is on 15% of the time. 85% of the time it is off. It has to remain off long enough so the coil can produce its electromagnetic flyback. You have to let the magnetic field fall back into the coil and wait until it discharges. I find 85% is best. Over 90% the circuit will not work. Under 70% the circuit will not work. Of course, that may depend on certain conditions, but that's what I'm getting right now for what I'm doing. As far as frequency goes, anywhere from 30 Hertz up to 8 kilohertz works to produce a nice strong light. I find if I go over 12 kilohertz, the circuit will not function any longer. So that's what I've got so far. Basically from my own notes, so I can remember what I did later on. I'm getting older, I forget things. And next, when I get more jumper cables, I'm using all I have, I'm going to try these small coils in series and in parallel to see how that does. One more detail about these automotive coils that I'm using. I'm only using the coil part, I'm not using the contacts. So here's what one looks like outside of its wrapper. I'll get my camera to focus. That's it next to a dime. That's the coil is less than ½ an inch in diameter, and you can see it in comparison with my my finger. Put my finger joint along this thing. There it is. These coils are tiny. All on its own is producing about 40 to 44 volts, depending on how much input you give it. And with a transformer involved, you can boost up to 120, 30, 40, 150 volts, so you can run some small appliances. So I find it incredible that this tiny coil can do that much work. Run out.